Hi everybody, this is Nafish. Today we are going to talk about tokenizers. So tokenize is nothing but break into small units. So just think about a paragraph. It could be broken down into some sentences, right? And also like a sentence could be broken down into words, and words could be broken down into letters, right? So basically converting into its smallest unit. Okay. So before we dig much into tokenizers, there are some use cases in natural language processing or in machine language models. Basically you do the tokenizers, you use it because we can do some text pre-processing, then train a machine learning model, then feature extraction, and also like pattern identification and many more, which are not listed here. So let's get started. First of all, we are going to import NLTK, okay, which is natural language toolkit. And if you do not have it, you can just download it. You can just do it you can do a PIP install. So PIP install and then NLTK. Okay. If you do not have it installed. So first you run it, you importing NLTK toolbox, and then from NLTK dot tokenize, okay, you press tab autocomplete, import. Let's go with word tokenizers first. So word tokenize, okay, you run it, and let's think of a sentence. Let's say our sentence which we are going to work on is hi there, this is the fish. What's your name? Okay, so this is our sentence. Okay, so we run it. So basically you can break down this string. So we just need to call word tokenize. So word tokenize, and then pass the input, which is s, and you see you get it is like broken down into words, right? So one thing to notice, like the punctuations, like this exclamatory sign right here, and then this question mark, they're also individual entity here. Okay, also this space right here, okay, this comma, this is also a individual entity. Now if you remember, in Python we have another thing called mm, split. So if we split this string, so s dot split this method, if we use this method, we will be also able to break it down into its smallest individual words, right? But if you compare, like, there are some differences, right? So basically here, uh, this is attached to this word, like the original sentence. Also, like, after name, this question mark is um, not considered as a different different entity or word here. Okay, so there are some differences, and but this is another alternative method to tokenize. Okay, but sometimes you want to get rid of all these not meaningful words. So there are some pros and cons using these two methods, because this is definitely faster. But let's move to the next one. So this is word tokenize, and then you can do sentence tokenize as well. So for that we have to import it. So from an LTK, the tokenize, import send tokenize. Okay, you run it, and then let's pass the sentence we used at the very beginning, which is assigned to a variable called s. So then run it. Okay, so you see, like, we have one, and then we have two sentence. Okay, you can also take the length. Okay, so if you do the length, and then you paste this argument here, you see length is 2. Okay, so you have two sentences coming from that the original string. Okay, so this is sentence tokenizer. You can also do character tokenizer. Like, for that, what you need to do is, like, just run a for loop. So let's say for I in s. Okay, and let's use some method. Let's say I dot lower. Okay, and this should be able to give you all the letters. So you see we have this many letters right here. We can take the length of this as well. So let's say len. Okay, and see how many letters there. So there are 43 letters in that sentence. Okay, so this is kind of, I think you guys have a good understanding of what does tokenizer mean, and why it could be useful in some of the machine learning model inputs or some of the text pre-processing.